Hello, and welcome safety enthusiasts to our SRES fireside chat. I'm Jody Nelson.
I'm Gokul Krithivasan.
And I'm Bill Taylor.
So first of all, anybody with questions during our discussion, please put them in the chat. We'll try to answer live. Otherwise, we'll get back to you offline. So let me first set the stage for our discussion. Where this is evolving from, we have weekly calls at SRES. We call them our technical calls with our team. And this is where we really discuss kind of challenging or difficult discussion points or challenges in the industry, in autonomous vehicles and AI. And actually, this stems back from many years before then. Back when Bill and I were kind of a two-person company, we organized one of the first ISO 26262 trainings. And this is, I don't know, maybe even before the standard was released, or at least the really early days, back early enough before anybody had ISO 26262 on the resume, right? So if somebody said they knew functional safety, generally they meant they knew IEC 62150A. And we're in this training session with a pretty full group. This is all in person. And the instructor was going through the quantitative analysis, specifically the FMETA. And it wasn't really going well. Like the concept wasn't coming out, and not that the instructor was doing a bad job. It just was a difficult topic. And quantitative analysis in automotive at that time was a fairly new idea, especially when we talk about safety aspects. And we recognized, during that discussion, is kind of near the end of the day, people were getting tired anyway, that people weren't getting it. And, I wouldn't say that they're about ready to bring their pitchforks out, but it was getting a little bit heated discussion. So we say, okay, let's end it for the day. So Bill and I went back to our hotels, and at that time, I don't know if this was Super 8, so at least some hotel I wouldn't bring my kids and wife to. So
It was
a
a
little bit
Super 8, I can tell you. It was the Super 8.
Super 8, yeah. So it was definitely sketch. And so we went back to a room and we're like, we got to figure this out. And we were up till early morning, kind of sketching out things, trying to build out problems and try to understand really how that FMETA works. I mean, ultimately what we found out in Annex B, if everybody recalls from the first edition, there's kind of like this flow chart of the FMETA, and it really wasn't correct, right? At least at that time, of how to explain how to do the FMETA. And Bill and I sketched something out that night or early morning. And when we started the next day, I asked the instructor, do you mind if I speak for the first 20, 30 minutes? Because, I think we've maybe potentially cracked the code here. And we presented that kind of new flow diagram. And all of a sudden we saw the head shakes in the crowd, right? Like we started capturing it. And it was really a rewarding feeling, kind of figuring out. And actually, that diagram we sketched out many years ago, we presented to the authors, and it's now in the second edition in Annex B. So that flow chart was something that actually was created in a Super 8 hotel room. Of course, it evolved over time as we kept on growing. Well, that kind of was our first, I would say, technical discussion. And we then introduced it into our company team meetings as the company grew over the years. And, we got feedback from employees at the time. It was like, oh, we love these discussions. I mean, sometimes they're very heated, going back and forth, sometimes no real answers, but follow-ups, we got to do more research. So we're going to try something new today. We're going to take that kind of idea, that technical discussion, and we're going to bring it to everybody here. So that's what our fireside chat's going to be on. So it's more of a discussion you have with colleagues at a coffee shop or at a bar or whatever you want to, environment you want to perceive. And the discussion we want to have today is on artificial general intelligence, AGI, but its relationship to autonomous vehicles. So we do hear this, every once in a while. How do you make a safe autonomous vehicle? There's a lot of different, discussions out there. One is on, hey, the only way possible is through general intelligence. But before we dive into that, there is a little bit of an elephant in the room. And we see Bill on this, and Bill's somebody from our past for sure, but maybe a little bit new to SRES. So Bill, it seems like you crawled out of retirement, like what's up with you?
Yeah, no, it's absolutely right. I retired, but retirement didn't stick for me somehow. So I walked away from the professional world about a year and a half ago, and I promised people at the time I was gonna spend time with my family, and I was gonna go fishing I've done a lot of both of those things, so I have gotten a good break in and kind of a good reset. Um, but over time, I'm just still interested in these topics, right? These are things that are of interest to me. Back in the old days when we were figuring out functional safety, it was very new, right? No one had it on their resume. ISO 26262 in the automotive space, it was new, and that was exciting, right? It was interesting and enjoyable to learn and sort of be the tip of the spear for some of that knowledge base, which is now really, I think, 15 years later, well promoted around the industry, right? You see a lot of application of all ISO 26262 and all functional safety, and that's rewarding, right, to see that grow. But when we look today, everything is now more and more, I think it's no secret, dominated by AI, and especially self-driving functions and full-blown autonomy, all AI enabled functions and features. And I think how exactly we make those safe, how we make them secure, and in a larger sense, how we make them responsible is a thing I just have a strong personal interest in. Of course, that's highly aligned. I would say exactly aligned with SRES's mission. So it was natural for me to join SRES, partly from a point of view of just interest level, and obviously. Second, but not last at all, is just the people, right? I've worked with you guys for a long time, many years, and so I'm really excited to be back in the fold and not only work with you two, but also some of the other really strong technical talents at SRES to just engage these topics. They're new now, somewhat the way that ISO 26262 was new, way back in 2010, 2011 timeframe. So yeah, it's exciting. I'm glad to be back.
Well, we're happy to have you here, and we've had a lot of discussions on autonomy and AI, dating back 2013 or whatever, and obviously it's advanced quite a bit since since
Sure.
those early days. So that's part of why we're here. So happy to have you here. Now I don't want to jump directly into AGI, right? Because that's kind of going into an advanced discussion. I guess we need kind of an understanding, like, how do autonomous vehicles work today, or what's the structure? So Gokul, I mean, can you kind of walk us through what a traditional autonomous vehicle is today on the road?
Yeah, yeah, of course. We've all been seeing some form of autonomy since like 2013 days, right? When we were sort of pulled into some garages and we were looking at these early architectures, even like cars being hacked for autonomy. But I think that's pretty evolved now to what I think we can put on a screen, talk about as an architecture. So typically follows a sense, plan, act sort of paradigm, right? Very similar to what we are used to in traditional embedded systems. We need a set of sensors to really understand the environment. So before we even get to that, there is, of course, the map itself, right? Like we as humans, we are sort of we have tools, we have maps, we had physical maps. Now we have GPS and Google Maps or Apple Maps, whatever we use. So we need some sort of a map for autonomous vehicles and so that they can plan these routes. And then these set of sensors can be cameras, radars, lidars to perceive the environment, put in obstacles in the environment. Also, the map can give you some information about traffic signals, maybe where the crosswalks are, those sort of information that we really need about the environment. Particularly interesting are like how do we like know where in this environment our car is? So we have to localize in some ways, right? Understand where on this map, where in this environment, our ego vehicle, what this autonomous vehicle is, where is that? And also the interesting part is the behavior prediction piece, right? As humans, we're really good at predicting, but now in autonomous driving, there are ML models that predict what these actors are doing, pedestrians, cyclists, other traffic users. So there is this behavior prediction aspect that's also sort of adjacent to sensing, but really key aspect of maybe post-processing what the autonomous vehicle sees. Then comes some of the harder aspects of autonomy, which like are very intuitive for people once we have some training, but for autonomous vehicles are hard. This is the planning piece. So there are two facets to that. One is the behavior planning. What does the autonomous vehicle do in response to the scene, right? What it sees and what sort of maneuver is this? Do I come to a stop? Do I continue driving? Do I change a lane? Right? These sort of behaviors, but also sort of planning so that's sort of the sort of response sort of action, but also like overall planning the route and how to get to the destination, so to speak, right? We're talking about level 4, SAE level 4 sort of driving, so going how to get to that destination. And then, of course, that involves generating trajectories. And these trajectories initially are like a bunch of trajectories that are maybe proposed by the compute. And then there is some sort of a supervisory control where it picks the best trajectory that is appropriate for that scene, for the set of actors. Then comes the piece that we are all sort of aware of, right? How do we take that trajectory and really convert that into acceleration commands, braking commands, steering angle commands, turn signals, right? There are a lot of, in level 4 autonomy, there are so many other auxiliary functions you may be responsible for. So this vehicle is responsible for providing those commands so that for the platform, it's somewhat agnostic, right? Like the platform gets the commands as if it would get from any other sort of control module in the car, and then it can execute those commands. So it becomes then a control loop. And the really interesting aspect, the challenging aspect is all of this happens iteratively every 10 milliseconds or something in that time scale. Right? That's what makes this challenge incredibly hard to sort of solve.
Yeah, so I mean, essentially, the vehicle has to take in some images or snapshots of time, and then has to know where it's at, and then it knows where it wants to go. As long as there's nothing, I guess, in the way, it will continue going where it wants to go. But there are situations where it might be something there that wasn't planned for, so then it has to change that, what you're calling trajectory, right? Like change the coordinates of where the vehicle is going to go. Okay, so that makes sense. I guess, so what's the problem then?
Well, I mean, let me jump in. I mean, we should say that. I mean, all that's right and true and correct. I also think we say it so quickly. It's worth a pause to just like look back on near term history, right? We don't have to go back decades. We can go back just years and start to talk about the ability to truly perceive your environment as a compute system with lidars and cameras and radars on it, and to really understand what's happening around a vehicle, for the vehicle itself to understand that. That's just an incredible feat. I mean, it's really amazing, right? It's dramatically better and more advanced now than it was 10 years ago when we started fielding requests for autonomy safety. With that said, when you talk about the problems, I think there's a couple general, how can I say, generalizable statements of what's still a problem or what's still challenging for these vehicles. I mean, they've progressed tremendously. They still have questions and concerns with how you verify and validate this end function, right? How the V and V of these is not trivial. It's not automatic, and it just includes some really thorny questions, especially because there's still edge cases, right? There are very rare scenarios that we don't encounter very often, that sometimes we don't even anticipate. What the SOTA standard, the ISO 21448, would think of these as like unsafe unknowns, right? Like scenarios that we didn't think about. We didn't realize they were out there, but that will cause a safety incident. And so discovering those and discovering those safely, and somehow assembling arguments that those are exceedingly rare, and or that we've found them and we've solved them, that we've done enough scenarios, that we've done enough miles, we've done enough testing, enough simulation. That's a really tough problem. There's a lot of progress that's been made on it, but I don't think that's not only not trivial, that's fundamental and a fundamental barrier for lots of organizations in this space. I mean, the other thing, which is I think is overlapped with that, is just complexities of ODD, right? For operational design domain, we understand that these are vehicles that are only meant to drive in certain locations and certain times of day and certain weather conditions. Just defining that ODD is a challenge for a lot of folks. I think also really being responsible to stay in the ODD, even when it's very tempting to sort of creep outside the ODD. We have to take ODD seriously, and that means both spending some time and effort defining what it is, and also installing safe capabilities which control us to be within that ODD at all times. That's been a challenge. Sometimes it's a mindset challenge out there. So those are a couple. I could go on and on. I think a lot of these have to do with the meta issue for all these is simply scale. It's just those two that I just mentioned are massive problems. and it's the scale that takes into account all the complexity that you deal with as a human driver, the complexity you deal with in terms of viewing your surroundings, understanding your own sensor data, right? Which for us is just our two eyes, kind of roughly camera-like. Understanding, interpreting, anticipating what will happen, and then plotting a safe course. We as humans do that at a tremendously high rate of success, and self-driving vehicles will have to achieve that same success or better success to be ethical, to be responsible, to be safe. That's a high bar. I think it can be met. I think there's some out there who are bordering on achieving it now, sort of roughly speaking, but it's a high bar, right? And we should just say there's tremendous scale there to be tackled. It's not easy.
Yeah, and I think we are seeing some of that transition towards like trying to mimic that complex function that we do in our heads, right? We've sort of started to see this shift over the past couple of years. Like there are games like AlphaGo that's being tackled with really what they would call as like one large neural network. That's a very complicated game. And now the ML models that are developed can actually beat the world's experts in those games. So I think those, and also with GPT and a lot of sort of research there, development there, advancements there, I think we are also seeing like, can we mimic the human mind in terms of how we navigate this complex world? And we're starting to see like what, again, there are so many terminologies for these, but I think maybe the one that I like is sort of the end-to-end version, right? Can we build a large enough neural network that can basically take in sensor data and provide commands, right? That's sort of like how will that neural network look? We are seeing already some organizations that are out there who are attempting this for vision-based end-to-end network, right? They have cars out there that's operating, robotaxis out there operating. So it's interesting to see like the challenges in that space, particularly like we talked about the challenges with the sort of classical architecture. It's it's even more challenging to see something even more opaque and try to understand whether that can do the safe thing. So I think it'll be interesting to see how can we really like imitate a human driver in navigating this really complex world, or like how do we do that? They even sort of have this concept of like imitation learning. So they have these expert drivers driving these routes, and that's basically the training data. It's really incredible to see. We now have access to more data. We have access to a lot more compute. Again, when we started out back in the 2013 or 2015, we saw server hardware in the trunks of these cars, right? And we needed a lot more compute. Now, I think maybe like you can get orders of magnitude more compute in a smaller form factor, and also like forms of compute GPUs that are highly capable, that can do all of this really complex sort of calculations and really churn through a lot of training data. So we see, of course, a lot of advancements in vision-based. To what we notice or what is out there, the multimodal, which is a lot harder, is definitely being researched. We see those things out there, and it feels like there could be some advancements and advantages of going there. It becomes simpler, maybe hopefully there are a lot of performance gains, but also it doesn't come without its problems, right? At least in SRES, we've been really deeply engaged in responsible AI, interpretability, transparency, to really try to provide that at assurance arguments. It becomes really challenging in an end-to-end model. So that's what I think the industry is heading towards. I think it's a direction that we need to monitor, but also I think we have a role to play to really understand how to build like the right assurance arguments for that world.
Okay.
So I can't help but smile when we call it this way with with perception, planner, prediction, vehicle controls, trajectory follower as the classical architecture, right? Makes it sound like it's been around forever. I mean, 10 years ago, that was like far out, right? And now it's like, yeah, that's the old way of doing it. But I mean, I think you touch on something really important there, which is which is that at least if we have, so if we talk about perception, for example, we have a perception algorithm, it's being fed by lots of cameras, and it's of course insanely complex, and there's a tremendous amount of AI there, but at least we have a feel for what goes in, and we have a feel for what comes out, and we can assess, right? We can test, we can simulate, we can make some assessment about, did we perceive correctly or correctly enough for a safe function? I mean, that's what I worry about when I hear about these end-to-end ideas, which in a certain sense take all of these large scale functions, just mash them together into some one massive AI model. I don't know how I'll debug it, right? I mean, it's not really observable. If that end vehicle, right, an end-to-end based autonomy as you've described it, if that vehicle makes a mistake, why did it make it? And I think that's always a struggle with AI, right? AI is foundationally not as explainable as human logic. I mean, that's just the nature of it. But at least we could divide it in chunks and say only this little piece is unexplainable. Now the whole thing is unexplainable. And for me, I feel like maybe that's a fundamental issue. It's hard for me to get my head around how we're going to make that better, make that different. So you tell me. I mean, is there a way to do that in a world where that explainability is? It's let's not say it can't be done, but it's elusive, right?
Yeah, it is really going to be hard. I think the ultimate question is, like, do we have performance gain in doing that? And is that performance gain good enough, great enough that you are willing to lose the debuggability, if that's even a word, right? Or interpretability or transparency?
Sure.
I don't think the answer is very clear. I think clearly there is a lot of motivation to go to a more complex, more larger sort of neural network. But you're absolutely right. I think that's the key piece is ultimately we are all accountable as an industry and as organizations who make these cars to showcase why they are safe, and it becomes just a harder problem to sort of solve.
Yeah. I kind of always struggle a little bit with explainability. If we look into like EU AI Act or ISO IEC 42001, which kind of tries to build frameworks around responsible AI and doing things the right way, explainability, transparency, these things pop up all the time. I think transparency is something we can do in automotive, and I think it absolutely has to be done. Where I struggle is explainability necessary to make a safe product? And let's go back. I mean, I think Gokul, you kind of presented two different AV architectures here. We have, what we're coining as the classical view, maybe more modular, right? Like we're looking at perception as by itself, kind of to Bill's point, that I can do V and V on that, and then classification and in all these different steps. Even in that classical view, though, so the vehicle is determined there's a bicycle in front of me, right? Like, and if I want explainability, I understand why did you determine that was a bicycle? Well, I can do heat graphs, I can do all these different techniques for that specific image and find out, oh, is this 34 different combinations of pixels that made the system think it was a bicycle? So now I've explained why. But for me to do that from image to image to image, it's exhausting, right? Like that's not like a practical means to an end, I think, that gets us anywhere. I mean, in certain cases, of course, definitely in near misses and things like this, we have to have deeper analysis. But having explainability from start to finish on every single drive cycle of every single decision that's made on the vehicle, I think isn't possible. But yeah, you now talk about this end to end, which even gets to Bill's point, like even foggier, right? Like I can't even like break it out into the modules and explain at a module level. It's just I have an input and there's some output. However, what's interesting what you said with the end to end, it kind of mimics more what we do as a human, right? Like as a human, when you're driving, you're not breaking up into steps. Like, okay, I took in that image. Now I'm thinking about it. Is that a bicycle or is that a boat? You're not going through that process. It just naturally occurs and you make some reaction. I guess that kind of gets us into the discussion of maybe general intelligence a little bit. But before we talk about general intelligence in like autonomous vehicles, like what is AGI? I don't know, Bill, if you can get any insights. What is artificial general
Sure.
intelligence?
Well, I mean, so a few notes on AGI, and you're right. I do think it's we probably talk about future autonomous vehicles in one conversation and AGI in another, but there's a lot of overlap. And I think as years go by, or maybe as days and weeks go by, they start to be more and more overlap. So the basic idea of artificial general intelligence, AGI, is simply AI which is capable in enough fields of endeavor that it can exceed our human intelligence in essentially everything, and everything that matters, or everything that's necessary to perform even very complex tasks. So AGI is, I think it's maybe a little bit of a Rorschach test, right? It is what you dream it to be, but you can imagine AI that, for example, is able to configure its own V&V simulation. It's able to write its own update to code. It's able to do its own research into and summarization of safety manuals of various component parts, and safety analyses to find what's needed in terms of redesign, and to design itself in a way, right? So and on and on. So AGI is this kind of general purpose compute intelligence, which I think the way it's framed is something that we should be honest and say there's some serious people out there who believe that's going to replace our intelligence, right? I don't know what we'll be doing. I don't know if we'll be still employed, or we'll be living on a beach at that point, or writing poetry and playing music, which are things AI can also do. I like to think we can do it better, but it's that's the frontier. That's what people are pushing for, right? Is it real or not? I mean, I'm a little bit, so first of all, I think way too many people out there in the AI world do a lot of describing what will or won't occur in the future. And I think we should all just be honest that we don't really know, right? We're all kind of guessing. It's new. Anyone who says here's exactly how AI will be, I just feel like it's not yet known in a way that we can really get our hand around it. I feel in what I can see for AGI, I think AI has a long ways to go before it can stitch together various different domains and be fluid within them. If you're an engineering developer, right, you're writing some code, you're testing some other code, you're looking at some system test results, you're describing in the very next breath, or the very next email, the budget for next year, and your personnel situation on your team, and your spouse may call you on the phone and say, hey, what are we doing for dinner tonight? And you just switch context between all these things very quickly, fluidly, and without confusion. But those are all very different kinds of dialogues requiring different kinds of inputs and different kinds of sensibilities. I haven't seen progress toward that multimodal integration into sort of one big AGI. I'm not saying it can't happen, but maybe for me, I feel like AI tends to be really good at the thing it's trained for, and tends to be pretty brittle, at least at this time, when we step outside of that one training and try to pivot into something else. So I don't say it couldn't happen, but I don't know. For me, if I'm honest, I'm a little bit skeptical of AGI. Probably it's a good debate we could have, and probably we could have, and we probably will have over the coming years as AI develops.
But I guess that kind of leads me to two questions. First of all, I mean, is there any product, like even outside of automotive, just in general, that actually uses AGI today? So that's the first question. Like, is there something that's using AGI? And the other one is, what is an intelligence? I mean, I know, everybody in computer science talks about the Turing test, right? And like, I don't know if this is the 1950s or whenever this was, but that kind of was the benchmark of, yeah, this is intelligence. So yeah, are there products today that use AGI? And then what is intelligence?
Yeah, I mean, for me, I haven't seen what I would call a true AGI product out there, but I see steps in that direction, or at least anticipating that direction. So we'll see, right? If we talk about the large language model Claude, it's able to do a decent job at writing code in some context. I don't think you can have it go write your code and turn your back on it, right? It still takes some review, some discussion, some deep prompting and input, but it can generate code. It can do so pretty efficiently, and some others can as well. I think Claude's maybe just the best one. When that can start to test its own software, when it can start to integrate its own software, when it can start to do software program management, where it reaches out to either other people or maybe other AIs to please redo this function, or we need to calibrate here, or this piece is old and needs to be refactored. All those kinds of things. That would be for me an AGI implementation for software development. I think we're not there. Are we going to get there? I don't know. I guess the future will tell.
And I feel like,
and many people sort of talk about, again, we've sort of seen some people wanting generalizability as a way of solving the safety problem, but we should recognize that that introduces also other problems, right? I think we all know about the no free lunch theorem, right? It's like it's not going to come without issues. So it's always a tuning and trade-off discussion. Like maybe there are gains there and we should monitor and look for them, but also be very aware of like the opaqueness and the generalizability. Also, maybe it learns in a way that is not aligned with the organization or not aligned with society, right? We should be aware of those as well.
Absolutely. I mean, that's a big deal. When we talk about something which has more general intelligence and which can take on more and more context, we often miss something that's needed, which is it needs more in the way of purpose or intent, right? Or goals. And we also can start talking about very higher level intelligence setting their own goals or having their own purpose. That's exciting to computer scientists. For many of us, that's a little bit scary as well, right? I don't think I want robots and cars necessarily having their own goals. I want to be able to set those goals so that they're not set in ways that are, to your point, Gokul, that are misaligned, or they're doing something we find dangerous, deceitful, overall, detrimental to safety, security, and all the other things we're trying to preserve. So yeah, I mean, AGI is a double-edged sword, right? It's going to be able to do a tremendous amount of work that maybe we don't want to do, but to the extent that it has goals and intents and aspirations, probably it's a bit concerning if it does arise. So we'll see.
And I mean, AGI now in the context of automotive, to kind of build up the argumentation that AGI is necessary for safe autonomous vehicle, let's say, stand on that podium for a moment, would indicate that, okay, AGI, as you mentioned, Bill, is kind of getting more towards what human intelligence is. And I don't want to define that here because I think we could probably spend a few hours on what is really human intelligence. But I mean, first of all, they have to ask the question, is modeling the human the best input for autonomous vehicle? I mean, in the United States, we're somewhere between 35,000, 40,000 fatalities a year in a car. I mean, maybe we do it good, but do we do it awesome? I don't know. We both had young kids and have seen outside of ourselves the progression of, how you can drive and things like that. I mean, is that really what we should be like? That's our golden standard is human driver?
I don't. Gokul, you want to take that one, or you want me to first? Your call.
So I think that's the fundamental question, right? I think ultimately, I think there is this marketing or what looks good, and maybe it's an endeavor to go and find out if there are other ways of operating in the world, right? But I think fundamentally it's a very human designed world, and we are trying to make these models fit human mental models, and precisely what you call out is sort of the weakness, right? If you get the world's best drivers to become your training data, that doesn't mean you are going to see every edge case or know what is the right reaction to every edge case. I think generally people, us when we drive, even like people who are very young who are driven or who are driving, like we tend to understand the experience, or we tend to sort of have these cues of other people and make decisions that way. I think there is not enough training data that's probably out there to make a really good AGI driver. And I think that's why it comes back to the point of like, what is the benefit, right? Is it really a performance benefit or is it a safety benefit, right? And how do we balance that? It's not very clear whether, like, I'm yet still not convinced, and I want to be convinced, right? Whether this AGI is really going to improve safety. And if it is, I think we should really support it and we should build arguments for it and help the industry. But I think we are still waiting for like what are the performance gains and what are the safety gains for us to maybe accept some of the risks that come with that. The answer is not very clear.
Yeah, no, it's a great point, and I think there are places where, I mean, Jody, you talk about whether human drivers are the right benchmark or the right, I don't know, the right level that we're trying to achieve, right? Does that really set the target? I mean, I think of 35 to 40,000 fatalities in the U.S. in a year. It's an astounding number, right? I mean, the number really should be zero. That'd be a good place to start and see what we come up with. I also think about, you know, the human fatal accident rate is very roughly speaking once per I think 10 million miles. I mean, I think about what my teenage kids went through to go get a driver's license, right? I think they drove for 20 or 30 hours and sat with the driving instructor, drove around the block, parallel parked once, and they're a stamped driver, right? Which is a little concerning to all of us. That's just the way it is. So I think we humans have a blind spot in that we kind of view the human way of doing things as like the right way or the best way. And that's natural because we've been pretty advanced so far, but there are other ways of getting some of these same jobs done. And machines in some limited places for sure can do it better. I think of some things that are a lot simpler than driving. You know, we've all sat and done detailed reviews of safety manuals, right? From people who make microcontrollers, SoCs, and GPUs and so forth. I mean, you're talking about a whole lot of data and information. And just to dig through and understand where, you know, where's the information that you need and how would you interpret it? I mean, this itself can be hours and hours of work and work with imprecise outcomes from expert engineers. This is a thing that sometimes an AI tool can simply do better, or can be a great assistance to someone who's really trying to get practical problems solved, trading off comparisons between 2 or 3 or 4 safety manuals, each of which are 2,000 pages a piece. I mean, it's really hard to do. It's laborious. So I don't see humans getting out of that loop, but I do see. I've heard AI it's been referenced as it's been called a cognitive prosthetic, and that appeals to me. That framing of it, I think, is about right. We still have to do the thinking, but there are places where AI will help us tremendously. So maybe that's an incremental viewpoint. I mean, again, I'm not high on AGI, if I'm honest, but I am high on artificial intelligence. I think it's a tremendously powerful tool. Maybe I'm getting old and I can't envision you know, new things as sweepingly as younger people can, but I still think humans will do the design, development, ultimately fielding of these vehicles. They have to show that it's safe, and they'll do that with the help of AI, but still with human decisions at the core. That's the future I can foresee. Things beyond that are, for me, pretty fuzzy at this point.
Well, I just want to circle back on one comment. I mean, I grabbed, you know, daughter 16 and had to watch her drive and things like that. And she had very limited miles, you know,
Sure.
before she got a driver's license. However, I think if, you know, somebody in the AGI trying to push back on that would say, well, it was actually the 16 years of experience that they had
Sure,
outside
sure.
of driving, you know,
That's right.
realizing that rocks are heavy and they can break glass, or
Yep.
watching their dad yell at the car that just pulled out in
Sure,
front of him.
sure. Or just ingesting, you know, millions upon millions of images and
Yeah.
how pedestrians walk, how cars move, right? Yeah, that's
I
it's
mean,
a fair point, right? You ingested a ton in 16 years.
yeah, before mile one, you know that a leaf, you know, coming in front of a
Yeah,
car is light and something not a big deal
sure.
versus a deer or something else.
Yep.
So I mean, there are, you know, it's kind of hard to compare, but I think also if we talk about AGI, I think we really have to separate out level 4 and level 5 discussion to some point, because if I go to both extreme ends, I mean, this goes to your point also, is like AI can, I think a lot of people agree, or all of us can agree, that AI can do some things a lot better than humans and some things just not as good as humans today, at least. But if I take my vehicle and I put a really restrictive ODD around it, right? Operational design domain, and it can only go 0.5 mile per hour. It's only allowed on this one block. I only allow it at 75 degrees Fahrenheit and no rain and all these kind of restrictions. Then I think AI, or, you know, even the traditional autonomous vehicle that Gokul mentioned, is more than sufficient. Like we don't need to argue AGI for that. But now taking that car and removing all those restrictions, getting into a level 5, you know, driving on I-70 here through Colorado in a snowstorm. Now, then I can't think the question is, well, does that traditional model still work in that environment? And in that case, maybe the discussion of, well, then maybe AGI is better or not. You know, like, I mean, I think for level 4, AI actually might be better than us in a lot of those cases. I mean, there will be incidences. We can't expect zero always. I mean, we want to design towards zero, but we can't expect it. So I don't know. Like for me, the AGI thing is more of, hey, if we're gonna get to level 5, and then it comes, is there really a business case for level 5? Do we need level 5? So I don't know, thoughts on that.
That's really key. I think we've been in this industry now for 12 plus years. And like if you really talk to the industry experts, they'll tell you level 5 is sort of a nice thing to talk about, but really not very useful in the near term or even in the medium term, right? Maybe long term the answer will change, but the near to medium term, that's not really in the conversation because the amount of effort, the engineering effort it will take to get there versus the incremental maybe benefit we get is probably not valid. I think just to sort of come back to some of this like end-to-end models we were talking about, there are companies out there who are implementing end-to-end, also recognize they need supervisory controls on top of that, right? Some rules based on top. So I think the reality which you're going to see is somewhere in between, right? Maybe the classical architecture has some holes, needs to be improved. Maybe there are some gains, but also I don't think our view of needing some rules-based supervisory control on top of that, right? I don't think will disappear. I think we need those also for our own sort of ability to confirm that it is aligned. It is doing what we are wanting that vehicle to do as an organization, as a society.
I mean, Gokul, you said something before that caught my attention a while back, just relating to the ability to be better, right? To have a performance gain, and that we could say, look, maybe an all in end-to-end pure AI system, which just took sensor inputs and gave brake steering and throttle out. Maybe it's less explainable, but maybe it is more capable. And I think the good news is that we do have frameworks for making that kind of assessment, right? For saying, look, what's the performance of this, and is it good enough, right? And I think you can go to the ISO 21448. At the end of the day, what that standard says, among other things, is that we're going to expose our autonomous vehicle to a wide variety of scenarios, all the scenarios that we've discovered, and we're going to keep a library of them, and essentially just make sure that every scenario that we think the vehicle will encounter, that we can traverse that scenario, and we can do so safely, right? And that additionally, that's sort of necessary but not sufficient. We're additionally going to expose ourselves to unknown scenarios, by which we mean simply real world exposure or simulated exposure that's meant to mimic the real world, probably both. And we're going to show that actually not only in our simulations of scenarios that we have imagined, but also in scenarios that just appear out of the sort of natural chaotic reality of the world, that we're safe enough, right? That we get through these with either no accidents or incidents, or at a very small amount, which is within our acceptance criteria. And so there is, I think one thing that people, yeah, as you guys know, I'm a big fan of the SOTIF standard. There's debates out there about the usefulness and intent of that standard. For me, I'm a big fan of that standard, and one reason is, no matter what, right? No matter what our ODD, no matter what our driving architecture, whether it be the so-called classical one or something more end-to-end and AI-based across the board, we have means of assessing whether it's good enough. They're probably not perfect, but I think they're relatively distributed across the industry now, and time will tell, right? Time will tell. There are ways to sort out, is there really that performance gain? I think what will be harder is if there is that performance gain, but we lose something in explainability, in traceability. How will that judgment and trade-off be made? And I think that's a really tough human judgment. I don't know how that'll be made. Let's say we have to get to a place where everyone feels good about what they have in terms of just the hard numbers. But we can develop those hard numbers with scenario testing and simulation for any of these architectures. And so I think time will tell, and we'll know the answers to some of these as all these vehicles evolve.
Yeah, man, I think that's an important point. I mean, we were in those rooms in the early discussions, 2013 and stuff, and it's always like, how many millions of miles are needed? Yeah. And now fast forward in 2025, you're seeing companies out there getting significant amount of miles. And obviously, miles is maybe not always the best metric, right? It's like how many scenarios or unique situations can we present it? And that's where I think, to your point, like simulation comes in key, right? Because you can throw in a lot of different simulated scenarios that are hard to, just time-wise, finding them in the real world and real testing. Now, one of the things that pops up quite a bit, and I'd be curious in your guys' view on this, and I know we dug into it many years ago, is the rant study, right? Like a lot of people point to that, and you get different views of it depending on, what I guess your perspective is. But like that's brought up as arguments, like how significant is that study, and are there any issues of how it is presented?
Yeah, I mean, I'll dive into that one, and I'm interested to hear Gokul's viewpoint. We studied that thing a long time. So for people who don't know, there was a study done by Rand, just asking, essentially asking, what would it take to validate the safety of autonomous vehicles, and it tried to put that argument or the answer to that question in terms of a number of miles, right? So how long would you have to drive an autonomous vehicle without incident to say, hey, that's as safe as a human, or safer than a human? And they came at that from a few different ways. And I have kind of a split screen of views. I have two views on that study, one positive and one negative. I think it's incredibly useful. I think they do all the right math when it comes to building these curves that would say, look, depending on your benchmark and depending on what confidence level you want, and depending on how you wish to calculate this, here's how many miles. And so I think the math in there is impeccable, and the math in there is very useful. It's a great useful guide to sort of understand the problem. It's the starting point for many people who study this problem. What I disagree with in a practical sense is the points on these curves within the study, the points that they select. So there'll be a view that says, well, here are some curves, essentially calculations that show potential number of miles that would be needed. But then they'll say something, well, if we want to be 95% confident that our fatality rate is less than human fatality rate, here's how many miles we need. And it's some very large number, way up in the billions. But I think in reality, there are other very valid, very useful points on that same graph, which are much more attainable and still tell us things that are important. We do, of course, care about the fatality rate of vehicles. It's definitely worth thinking about. It's definitely worth tracking. But we also take in data from things which are non-fatal but still wrong. If we have a collision that causes an injury, if we have a minor collision that causes no injury, or even if we have a near miss, right? We say, hey, we did something we knew was wrong. There was no injury. There was no ultimate outcome. But we can track the rates of these things, and we can track those against human rates. And we can find very valid, very valuable, and very relevant safety information, which is credible as safety validation information at dramatically lower numbers, just by moving to a different curve, a different point on the same curve of that Rand study, and easily get to make very credible statements with mileage numbers more, let's say, very roughly in the range of 1 million miles, depending on what we're looking for and how we do it. So I like the math that's in that study, but I think the reality is it doesn't show at all that we need billions or hundreds of billions of miles to do relevant practical things. Safety can be shown, can be demonstrated in a very real way with a much more tractable number of miles. And actually, I think there's some players out there that are now or will soon have those kinds of miles to make those kinds of statements.
Yeah, and I really agree with that. I think that's one, we need to make engineering judgments, right? That's a key aspect, and there are subject matter experts within the ADAS, ADS industry who deeply understand and can make the right adjustments, and of course have to defend those assumptions, right, and be accountable to those assumptions. I think another aspect or a personal sort of observation for me is it sort of just completely integrates everything, right? We can look at human driven vehicles in terms of fatalities, injuries, crashes, but really from our experience, we have to look at maneuvers. We need to look at, okay, how does a human driver perform for lane changes? Or how does a human driver perform when entering? Do they enter in the wrong direction in a one-way lane? And how often does that happen? That sort of data is hard to get, but that's, I think, a better comparison, because the ODD for these vehicles, because it's level 4, it's always going to be limited. Therefore, comparing it with these sort of large, broad sort of statistics is not the right comparison. It's not an apples to apples comparison. So we need a better comparison, which means, to Bill's point earlier about ODD, the ODD matters. So the use cases within the ODDs matter, the scenarios matter, and can we boil that down into, like, these are maneuvers, for instance, taking an unprotected left turn. how many accidents happen, right? In those sort of world, and in the geography where I'm deploying these cars, like how many such accidents happen. I think that's a better comparison to make the people within those ODD, the customers or the users, the general population within those ODDs feel comfortable, right, with those numbers. I think that's some of these studies are very helpful as a thought exercise, but really when you get to implementation, you need to make the right comparisons, and that's the hard work, right, to do in safety.
Totally, and just to add on to that, I totally agree with that, and I think one thing that's often underestimated by those of the traditional vehicle background, which look, I am as well. Right? I've been doing autonomy safety for a decade or so now, but the decades before that, I was doing regular automotive stuff, right? As we all were. There were no self-driving cars back then, and we were conditioned. Some of us old timers with gray beards around here, we're conditioned to think in terms of approximations for how often does a certain scenario occur. We use engineering judgment for it, but oftentimes, more and more pervasively, there's data where we don't have to guess, right? If we were to say, well, that's only a concern when the sun is setting behind a traffic light into a left-hand turn that's unprotected, where you're and a vehicle's approaching at a certain speed, we would in the old days say, well, we can't possibly know how often that is, right? We make an order of magnitude estimate of how often that is. With modern vehicle data collection and the big data that's come, it's come really to power a lot of the mapping and AI functions, but it has an ancillary benefit, which is we don't have to guess at how often that happens. Now we know, right? We can know how often. And it's a very powerful idea that we can really parse these sort of scenarios in a much more detailed way, a much more granular way. And to your point, Gokul, we can then get in a room and say, hey, this challenge, here's what we've seen in test, here's what we see in simulation, here's the most critical corner cases in terms of perception, and here's our performance, and is it good enough? And we just have a lot more data than we did a decade ago, even a lot more than we had even 5 years ago, I think. The smart players are out there using tremendous amounts of data, and they're reaping the rewards of it, right? There's more and more that we see, a large number of miles being accumulated, which are valid and which are useful and which are based on exactly these kinds of hard engineering exercises. But the key difference is hard engineering exercises based on data, right? Based on field data that can really be turned into something quantitative. So yeah, I'm high on quantitative methods in this space. I think they are informed by data in a way we could have never imagined even 10 years ago.
So I guess, kind of summarizing what you guys are saying, I mean, it ties into kind of the RAND study. I mean, we're all trying to find, I think a lot of these standards say acceptance criteria or some kind of mark that says, yeah, we feel comfortable enough to move forward. And if we look at a lot of these standards, what we've been saying here is like there's infinite scenarios, right? Like, and which would mean infinite data is required to 100%, which would mean infinite time, which means there's like, let's just close shop today because it's not going to happen, right? So everybody has to get that kind of, I guess, warm feeling in their stomach that, hey, we believe we've done enough. It's sufficient enough. And what you're saying, tons of data, driving simulation, and these standards build around, do you have a good process? Do you have, kind of audits or reviews around those processes, and you're following like this. Now, I want to bring this back into AGI versus what, Gokul defined as traditional or classical autonomous vehicles. So even in this classical, again, I think we all smile saying classical to this autonomous vehicle, but
it's a great term, actually. It's,
it's just hard to say, but I guess it kind of makes sense.
Yeah.
But even in that, it's using an ML model. And if we're all honest with ourselves, nobody in automotive that's working on ML models understands what the heck is going on inside of that model, right? Like they're changing weights and they're doing these trainings and all these kind of things, and they get some outcome. So I mean, there's a lot of black box activities to it, and then Gokul, you transition to the end-to-end idea, which is maybe even a bigger black box with capabilities to test inside. But then when we move to AGI, then it's like, well, somehow this thing kind of thinks like a human and kind of does things that we would expect a human to do. It looks really like a human. Now, putting a harder question on the table for you two and putting you on the spot, us as an organization, we don't do ML models. Like we don't write the code, we don't train data, but we work with companies that do. we're concerned about safety. We want to make sure it's a safe product out there. It is somewhat a black box. So does it really matter if it's a classical black box or if it's the AGI black box? With the standards we have today, 21448, we have 8800, we have 5083. These kind of standards help framework it. Is there anything we'd have to do different if it was AGI inside of that driving that vehicle versus classical or end to end?
Yeah, great question. Yeah, the simple answer is no, right? And I think we all have looked at these standards and found areas where there are great pieces of information. We really agree, right? It sort of distills a lot of great thinking out there, but also there are places where the standards can have some weakness or doesn't give you prescriptive guidance. But the great thing about both the sort of standard, which is the 21448 standard, and some of these emerging standards, right? The ISO 8800 for AI safety, the ISO 5083 for ADS safety cases, safety performance indicators, those sort of things are agnostic, right? They are not dependent on the technology that you use or your architecture. It's really building the right argument. And what is great with these standards, and of course, when we come in, these standards are tools, right? If we come with the standard as a checklist, then I don't think we're going to make a lot of great progress. It's a good frame of thinking. It gives us the great tools and the methods and ways to really do it responsibly in a way we can defend. But none of these standards are going to tell you, oh, for convolutional neural networks, you will do this. But let's say a reinforcement imitation learning is disallowed, right? These standards are not intended for that. There are really good ideas here that are applicable, and it gives the flexibility to the organizations to build that argument. And we are seeing now, and we are being involved in a lot of these safety case argumentation where as part of your safety case, you can also add defeater arguments, right? You can build live safety cases where you yourself can add some defeater arguments and provide counter evidence to that. So these standards are very flexible. I think our view is the technology doesn't really make a difference, right? It's really about what you can really defend in a way that is responsible, and you can back it up with the data, right? To show that you actually met those. You just didn't claim it, but you actually have proof from the real world, from simulation, that you actually met these metrics that you said you will meet.
So I'll agree with Gokul mostly, but not entirely, just so we have a little good spirit of debate. I really agree that just as Gokul said, the ISO 21448, the SOTF standard, and also the more recent 8800, so the AI standard, these provide technology agnostic or implementation agnostic means of doing things safely and assessing whether they're safe enough, right? And again, with scenario testing, with scenario simulation, with looking for known scenarios, with making sure we've statistically found a certain critical mass of unknown scenarios, and best practices of process whenever we're dealing with AI and some of the nitty gritty that's in 8800. All that I agree. I think that can be applied and can be applied effectively even to this sort of futuristic end-to-end concept. I want to get back to the idea though of explainability and traceability. It is certainly true that if we look at anything that's AI, right, and this goes for perception modules, path planners, futuristic views of all in. It goes for large language models and AI that plays chess and Go and games like this. For all of them, it is certainly a challenge. It's a challenge of diminishing returns to try to explain in human language what's happening in these systems, which are fundamentally pattern matchers. And so the challenge of that is real. But with that said, I think we can never fully explain what these systems do or how they do it, but I think we can go the first level. And sometimes that first level is all people want. And what I mean by that is to say, if we were to say we had an incident on the roadway and we say, why did it occur? You're right that in a current system, we would say, well, something in a perception algorithm, we don't really know, right? We've perceived that thing before, but something about it, it was kind of a one-off hallucination in some kind of edge case. For sure, that's a risk. So we don't really know, but the idea of narrowing it down to perception and saying we had a problem seeing things, right? We thought we could see everything, but we just got confused in this one case. That itself is a very powerful statement. We can't peel the onion back to the center to find the core of it, right? Because there's no heart of it, right? It's all pattern matching. But the first layer of being able to explain things, I think, is very humanly important, right? It's the kind of answer you'd want to give, to someone who wasn't steeped in these methods and didn't really know safety science or AI. They just want to know what the hell happened. You want to give one level of explainability. I think that first level of digging is tremendously powerful. And I feel like that's more accessible or more available in some systems than in others in AI. So yeah, for me, it's like it's diminishing returns. We can't ever explain it all, but maybe we need to try to explain a little bit. And I think for that, again, I'm now the guy with the gray beard around here. For that, the classical architecture maybe is preferred, at least for me.
Yeah, kind of a modular approach where you can kind of break down each one,
Sure.
at least explain at some level versus
Yep.
clump it all together. I can't really break out the testing. I can't really explain, the end to the other end, kind of thing. Well, so this has been a great discussion. I think we could probably go for a couple more hours easily.
And we probably will off camera, right? So
Yeah.
yeah, to be continued.
We do have to wrap up, but maybe I'll just one last bullet question, kind of closing out where we started. I'll start with you, Gokul. Is AGI required, necessary, to make a safe autonomous vehicle? I mean, is that the only way we can make a safe autonomous vehicle is AGI?
No, but I think there are claims out there that that's the only way to do it. I think I would love to see the seats of that claim, but I think that's a bold claim without a lot of evidence we see in the real world, right? I think I would love to understand where the performance gains are, where are the gains, and then the right safety mind then wants to sort of challenge that idea so that we can build a good argument, right? I think I'm open to it, but I've not seen evidence to point to that in all of our experience and autonomy.
All right, thank you. And Bill?
Yeah, I'll agree with Gokul on this one. The answer is no, not only not required, but for me, not even preferred yet at this point. I think it shows, though, a thing which is in my view, a kind of an error or a slightly wrong mode of thinking, which is like, when in doubt, we can refer to AGI. I think AGI is largely a Rorschach test, right? What is it? It kind of depends on what you imagine it to be. And I think we can always imagine things and how they might be, right? I mean, I can imagine unicorns and rainbows as well. In the real world, we have to build real AI systems that do real things, perform real functions, and are useful and are safe and are secure. And I feel like AGI maybe is a stand-in for a statement of something like, I don't like the way it is today, or I'm skeptical of the way it is today. But when you get in and do the real work on it, I think you see AGI is maybe, if I'm honest, a little bit of it's too strong a term. I'm not totally dismissive of it, but I think it's a little bit of a sideshow. The reality is the way things are made safe is people who know a lot about safety and a lot about how the vehicles are made have to really study, really grab data, really build a good safety case, follow standards, follow industry norms, do the hard work, right? That's how things are safe. And I think that's how they will continue to be safe in the future.
Yeah, I guess I'll end with my own answer. So I cheated. I let you guys talk first, so I can steal your answers. So
Great technique. I use it all the time.
I mean, I would agree. I think, Bill, like what you said, I'm a big fan of AI, like you stated, and maybe I'm skeptical, and maybe I listened to too many podcasts, and I should have built my aluminum hat. I was going to build one and put that on here, but the fact that we can't really define what intelligence is, and that it's still kind of a theoretical idea, and things like that. I see it something in the future. Like I'm not going to. I don't know what happens even a year now, right? Like every time you go to bed, you wake up in the morning and you're on a chat GPT 32, like, oh, what the world just changed, so I can't predict that. So for me, I buckle it. That whole question for me comes down to level 4 versus level 5. Level 5, something we haven't achieved. Like nobody has a level 5 that works out there perfectly and runs around, right? So maybe AGI is necessary for that. I don't know, because I don't know what really AGI is. And I don't think anybody can really define what AGI will be since it doesn't exist. So then I'll bucket with level 5, maybe. But in the world we live in today, level 4, I think then it just becomes an ODD question. And if it's unlimited ODD, I don't know that our technology today is sufficient to. I live here in Colorado in the mountains, snowstorms, but I'm seeing cars off the road all the time, semi-trucks on fire, all these things, like almost every day, at least once a week, right? But I think within a level 4 space, and if the ODD is appropriate, I think there's no need you need something beyond what we have. I mean, we improve sensors and we can improve compute and GPUs and all these things that help, of course. And you know, even if we look a year back, the whole world is different, right? Like you see these GPUs come out of the space where we said in the past, there'll never be an ASIL rated GPU. And then all of a sudden, boom, oh, there's an ASIL rated GPU. Okay.
Yeah.
So never say never, I guess. Those kind of things. So, okay, well, it's been a great discussion. For the crowd, again, put in questions in chat. We'll try to get back to you. And then we'll try to take some of the comments and questions and maybe have another round of this. I always enjoy getting on the phone with you too. It's enjoyable as always, you know, for the last plus, I don't know, 15 years now or so. So great. Well, thank you all for tuning in, and hope to talk to you soon.
Absolutely.
Yeah.
Thanks, everyone.
Thank you. Really enjoyed it.